Hey class, last video for 2D waves, at least for this week. We'll have some other stuff next week. But for our last little video, we're going to talk about some wave behavior. And what does water or sound waves do in a certain situation. Okay, so this is going to be really kind of good, this is me going through that 2D investigations worksheet. And this is exactly, again, what we would try to be doing in the classroom is we'd be playing with water waves to see what sound and light and water waves do in certain situations, okay? So I'm going to go through a couple of videos here as well, use the interactive little tools that we have and kind of try and teach you in certain situations what would waves actually do, okay? So the first thing we're going to talk about is, ooh, that's not what I want. First off, let's go back this. Oh wait, it's on, I can see myself. All right, I want to go over here first. So this is the document called, I think it's called Two-Dimensional Wave Reflections, okay, or it's called 2D Reflections. It's in your actual file folder. It's a PDF file, it's notes, it's really, really good notes. It's not just on reflections. The name's a little Italian, but it does talk about wave behavior really good. The first thing that I want to talk about is what's called wave propagation. It's a big word for just saying what happens when ripples or water drops in, or a sound, we call it kind of a sonic boom, where if I were to create sound from one spot upwards, what does it actually do, okay? Same thing, if I have a water tank and I drop a water in, what happens? And you guys basically already kind of know the answer to this. But we kind of see here in this instance, we can kind of see that there's basically this person with a water table, and we want to see what happens when we actually drop water in. Okay, and I'll try and get a little bit out of the way here. And so we can kind of see right there. When we drop water in, okay, it's going to spread out like a ripple in all directions. And basically that's just what wave propagation means. It means when a wave is started from one single source, okay? Sometimes it's called single source waves. Basically, if I were to drop one little water droplet in, that's one source. Or if I were to have one speaker, okay, in the middle of the room, what does it look like throughout the room afterwards? And basically, the ripple is going to spread out in a very circular way, okay? Again, that sound is going to spread out all the way throughout the class, okay? And that's basically what wave propagation is. And I'll go kind of back through the notes and kind of show you as well. So if I go back, we'll have to get out of here. All right. If I go through the notes here, you can kind of see it here, okay? If there's a single source that created some kind of energy, some kind of wave, it would, again, extend in all different directions. It would want to go in 360 degrees in every single direction possible, okay? And so that's sound, light, waves. Again, if I have a light source, that an actual light in the middle of the room and shine it upwards, it's going to create a big cone effect in a circular pattern. So that's exactly what wave propagation means. Okay, so that's the first word that is on the assignment that you may not know, but again, that's what that term kind of means. Also, let's talk about what happens when we have kind of waves interacting with other things, either at angles or whatever it is. So I'm not going to talk about reflection too much because I talked about that enough. If a wave comes in exactly 90 degrees, it's going to come back and bounce back exactly. This is kind of exactly. If you have a ball and you bounce it straight down, it's going to come straight back out. If you take a ball and bounce it at an angle, it's going to bounce at an angle off of it. So here's our angle. I throw a ball or have a wave and bounce it, it's going to bounce off in that other direction, okay? I won't talk about that too much because I talked about it in the reflected waves, but I do want to talk about what if it hits something that's not exactly, what if I have this? What if I have a little droplet here and then a barrier here? What's going to happen? What's going to bounce back, okay? So you can kind of tell that this is going to bounce back. This is going to hit first, and it's going to, again, bounce straight back. Now this, when it hits, is going to bounce in this direction. This is going to bounce, eventually when this one hits, it's going to bounce in this direction. But the nice funny thing is, after a while, when it comes back, it actually creates the same exact little circular pattern. So you can kind of see after a while when it gets big enough, okay, it's going to create a circular pattern on the way back. So eventually you'd see more and more circular pattern on the way back. You'd see bigger waves coming like this, and it would continue to get bigger, more on and on and on, okay? But it's basically, again, you kind of see here, whatever came in at that angle is going to come off at that exact same angle, okay? Last little one here, what if a flat wave hits something very, like again, curved, okay? And again, this is all we'll be doing in class. We would be taking these curved things, we'd be bouncing water into it. So it's not nearly as fun as this, but I still kind of want to get the theory off of this, okay? So in here, if I take a flat wave and I push it and it hits something curved, what's going to happen? And this is what happens all the time in like music theaters and that kind of stuff. When the sound waves will go up, and basically they have these big tarped off things on the actual ceilings. And why? Because they want to bounce the sound back to basically where all the people are. So let's say the crowd was kind of in this general area, okay? Sure, you're going to get a lot of the sound the first time, but then they create these big, nice, huge actual tarps to bounce the sound back. And what it does is it brings the sound back to a certain location. This is going to bounce off. Again, this barrier's curve. It's going to kind of bounce back in this direction. This one's going to bounce in this direction. This one's going to bounce this way. And it's going to bounce it all back towards here. So you're going to get a wave that looks like this. And then it's actually going to get smaller, and then smaller. And then it's actually going to flip and get bigger like this eventually. Okay? And it's going to flip. So it's going to bounce into each other, and then it's going to start rippling back out. So here we have the next kind of steps. So you can kind of see, I'll remember my red things, and you can look at the black lines here. We can see that the energy from these actual wave fronts, you can kind of see, again, bounces back in towards it. And then afterwards, after enough time, it's going to bounce and keep going. So you can see this eventually just keeps going the same pattern. This one keeps going the same pattern. So you eventually you'll get this larger wave that will continue to move in that direction. Okay? So we're able to kind of manipulate these waves as long as we're able to create barriers that we want. Okay? Waves follow two very strong rules. Okay, three actually. We have reflection, diffraction, and then we have refraction. Refraction will be all next week, don't worry. But what I want to focus on this week was diffraction and refraction. Diffraction and reflection. So this is still just talking about reflection. It's a wave that reflects. Unfortunately, it's a curve, but it still follows that kind of 90-degree normal rule. If I were to actually take my little protractor and make a 90-degree line, it'd be here. And then it gets smaller and smaller as I go. Right here is going to bounce straight back up. Okay? So we're able to kind of use these two rules to kind of play with water and sound as we kind of want. Okay? Last thing that I wanted to show here, I don't know if I already said that last time, but last thing I want to show is this interference. Okay? On the assignment, you will see this weird pattern. Okay? And I'm asking still to talk about destructive and constructive interference. Okay? And so basically on here, what I'm looking at, I'm going to give a big hint, but if you've watched all 4 videos and you've gotten to here, you totally deserve a good hint on how to do this, okay? On this actual thing, it's asking like, can you show me where constructive interference is and where destructive interference is? Okay, at the bottom of this worksheet, you see that the thick lines are crest, so this is a crest, and the dotted lines are troughs, okay, so trough. So where am I going to see constructive interference? Well, anytime I see crest and crests meet, and troughs meet, that is going to be good constructive interference, okay? And if light were to be, like if these were two things of light, which I think I talked about it is, there are two lights. If these are two light sources, you would see a very bright pattern of the light there, whatever kind of light you have, all right? Let's go opposite. Where can I find destructive interference? Again, that's where a crest is going to be a trough. So where can I see the solid lines meet up with the actual dotted lines? Well, you can kind of see a pattern here. There's one, there's another, yeah, and there. So I'm going to kind of just do this here now. So this is constructive. You can kind of see here, we have an alley of destructive interference. Destructive. And so if I was a person standing right here, looking this way, what would I see? Well, technically you would possibly see no light at all, because it's canceling each other out. Okay? We've gone through this interference kind of back and forth. This is just another way of looking at our constructive and destructive, is from that kind of two-slit experiment. So this question is just asking you to find all the constructive, all the destructive, and then again, if this was light, what would you actually see there? Here in the constructive, you'd see the most amount of light, you'd see they're the strongest. In those destructive patterns, you see basically no light because they're canceling each other out. All right. Hopefully this week goes well for you guys. If you have any questions at all, or you want to come in and play with the water tables this week, next week, let me know. Hopefully I get to see somebody in here. If not, hopefully everything's just going well. All right, class. Thanks so much. The assignment will be up right for today, so it'll be all good. All right. Hope you have a great weekend. Thanks.